Assalamualaikum and hello everyone. Welcome to the video for 3.1 Galvanic cell. In this video, we will look at the examples where we will express the half cell equation and the overall cell reaction equation, as well as use the standard reduction or electrode potential values to calculate standard cell potential. So on your notes, it will be on page 7. Okay, so for this one, for the examples on page 7, we will combine what we have learned previously. Okay, so let's look here. For the following cell notation, write a balanced chemical equation and calculate the standard cell potential. Okay, following cell notation, if you still remember, it follow the A, B, C rule. So, for example, here is my A, here is my B, here is my C. So, what is A? A stands for anode, B stands for bridge, and C stands for cathode. Okay, so first one is actually write a balanced chemical equation. So from all the following cell notation, what you have to write down is you have to write down the anode and the cathode, and the last one you can, once you simplify the equation, you will get your overall or the balanced chemical equation. Okay, and the next one is to calculate the standard cell potential. Standard cell potential is calculated using this formula: E naught cell equal to E naught cathode minus E naught anode. Okay, so previously mostly we have talked about oil rig or anox and red cat. Okay, based upon the E naught value, it is important for you to remember. Okay, for if the value is more negative, so it will be at anode, while the value is more positive, so the E naught value or the species will be at cathode. Okay, so here when E naught cell is equal to cathode minus anode, cathode more positive, anode more negative. Because sometimes the value given to you is both is a negative value, or both of it is actually a positive value. So how to determine which one cathode, which one is anode? Cathode is more positive while anode is more negative. Okay, so this is actually what we have learned previously. So we will combine all this information and answer the question together. So let's do it together. Example E. So here is the cell notation. So I have to label. First thing first, I'm going to label which one anode, bridge, and cathode. So once I have labeled it, so let's write down the equation. Because to find out the overall cell equation, we have to write down the anode and cathode. So anode is my magnesium solid. Okay, remember anode is oxidation. Oxidation is losing electron. So what we have to write down here is not plus electron. You have to show the arrow. So the product is Mn2 plus aqueous plus 2 electron. So again, when we check losing electron, so that is the equation for anode. Next thing is actually you have to check whether the equation is balanced or not. The atom as well as the charge. Okay, so when I calculate the charge here, so I get both sides 0, so it is balanced. Okay, next equation is for cathode. So cathode, okay, the first species we have here from the cell notation is Cd2+. Okay, so write down Cd2+ equals, again, cathode is reduction where it gains electron. So plus 2 electron to get the Cd solid. Okay, cadmium solid. So next, check whether the equation is balanced or not. So cadmium, we have only 1. Okay, and then for the charge itself, for both sides, we will get 0. So the equation is balanced. So when you write down the anode and cathode, make sure the equation is balanced. Then you can write down the overall cell equation. Okay, so for the overall one, what we're going to do is we will simplify the equation. Okay, simplifying by how? By removing the electron. Because remember, redox is the process where we gain and lose electron. So we do have our lose and gain of electron. Then we can simplify because it has the same electron. Okay, so we can simplify it straight over here. Okay, if the electron is not the same, now what should we do? If the electron is not the same, you have to multiply all the value, all the stoichiometry to get us the same electron. Okay, so now what I'm going to write down is actually I'm going to combine all the reactant on the same side, and the product is actually on your right hand side. Okay, so this is actually the overall chemical equation or the balanced chemical equation, the first question one. Okay, the second question, what it wants is to calculate the E naught cell, which is kakak tolak adik, or is actually cathode minus anode lah. Cathode must be more positive, anode must be more negative. Okay, so when we check here, okay, just check je, regardless kita ada which one anode, which one cathode. Okay, so kita tengok this value, both is negative, but which one is more positive? Since it is a negative value, which one is nearest to 0? That one is the more positive value. So cadmium is the one with cathode, magnesium is the one with the anode. So just check it together yang ini. Tengok sama pula tu dengan cell notation. So we have double check it, double cross check. So we can calculate the E naught cell equal to E naught cathode minus E naught anode. So cathode is my cadmium, which is supposed to be more positive. So betul lah, it is more positive. So the value is negative 0.4. Minus the anode is actually my manganese. It is more negative. So when we check the value, it is more negative. So we have a cross check. So you know that the value is 0.78 volt. So this is actually the second question. Okay, so that is for question A. So we have answered both of the question. Okay, so for question B, I believe you could try yourself. But then for the chemical equation, make sure simplify it. Make sure the electron is the same. The electron is not the same, we have to multiply this stoichiometry lah. Okay, so that's for question B. Question C, let's do it together here. So it follows the ABC rule. So this is bridge, this is anode, and this is my cathode. Okay, so for my anode, okay, so when I write down the equation, okay, here we have platinum. So what is actually platinum? It is an inert electrode which do not involve in the chemical reaction. So we don't have to include it in the equation. We can start with the hydrogen gas. Okay, remember, anode is the one oxidation where it will lose electron. So we will draw an arrow straight away. So when we draw the arrow, the product will be H plus aqueous, and then we have our electron because this is process where it loses electron. Okay, check whether the equation is balanced or not. So the atom and charge. Okay, so first check atom. Okay, on the product side we have 1 hydrogen, so we balance it by 2. And then check the charge. So when I check the charge here, to make it balanced, we have to add 2 electrons. So here the charge on both sides is 0. So that is for anode. Next is for cathode. So cathode, okay, originally is Cl2 gas here. So Cl2 gas, we will write down Cl2 gas. Okay, remember cathode reduction. Reduction is the process where we gain electron. So we have to add electron here. And then what is the product? Okay, based upon the cell notation itself, the Cl minus aqueous. So write down Cl minus aqueous. Okay, so make sure the equation is balanced. Okay, here the chlorine is not balanced, so we have to add 2 in front of it, minus. Okay, and then when the charge itself is not balanced, we're going to add 2 electrons on the reactant side. So on both sides, we get a balance of negative 2. Okay, so make sure when you write down the equation, it is balance. Balance what? Balance the atom first. Okay, next balance the charge by adding the electron. Okay, so for the overall one, we will simplify it by simplifying the number of electrons. Since the number of electrons is the same, so it's quite straightforward. We're going to cancel out the electron itself. Okay, and then make sure the reactant are on the reactant side. The product must be on the product side. Okay, so this is actually the product H2 gas plus Cl2 gas. We will get 2Cl minus aqueous plus 2H plus aqueous. So actually, for the overall side equation itself, you can see the equation is balanced as well. So right now, let's check to balance the charge itself. So negative 2, positive 2. Okay, both sides we get 0. Okay, how about the atom? On the reactant side, 2 hydrogen, 2 chlorine. The same goes for the product. So the equation is balanced. The platinum is both the inert electrode, so we don't have to include it. So why do we have our inert electrode? Because remember, for the ABC rule, we have to start and end with the electrode. The electrode must be a solid. So that's why we include the platinum solid, which is inert electrode. Okay, so that's the first question. The second question is the E naught cell. Kakak tolak adik. E naught cathode minus E naught anode. So to double check it again, cat must be the more positive, anode must be more negative. So since both is positive, so we will take the bigger value to be the more positive. So this one, chlorine is more positive, so this is the cathode, and hydrogen is anode. So this is actually a She, so that's why the 0.00. Okay, so cathode, when we check it, is the same, the more positive one, and our Cl2, and anode must be the more negative, and then when we check it, it's our H2 as well. So just substitute the value, so we get 1.36 volt. Okay, so that is the solution for question C. So for question C ni, yang lain dia make sure the equation is balanced. Check one by one by starting anode cathode. Question D, I believe you could try it yourself. Okay, so that's it for this video. Make sure, if anything, remember NOx, red cat. Lepas tu, ox to oil, oxidation is losing, red cat. Reduction is gaining. Okay, so that's it for this subtopic.